All right, guys, welcome back. In this chapter, we are going to write our first smart contract. I feel like we have been talking a lot, but we have not written a single line of code. It's time to change that. So we have Remix open up, and as you know, you can open up the File Explorer and you hit this button, this plus button, and you can open up a new file. We are going to call it first contract.sol. This SOL stands for Solidity, and that's the type of our file, like Solidity file. So it's first contract.sol. Cool. So what should we do in our first contract? It has to be simple. It cannot be anything too complex, but I kind of want to show you a few things. So I have thought of it and I came with this. So this is what we should do in our first contract. In our first contract, we should declare a state variable called count. We should have a getter function that gets the state. So it gets the value of the count every time we call that getter function. Then we are going to write a function that adds a number to that variable. It's going to be whatever number we pass to that function. And we are going to write another function that subtracts from that variable, and it's going to be almost like this addition. Whatever number we pass will get subtracted from that count variable. So where do we start? Well, the first thing that we should do, well, before that, I would use the latest Solidity 0.7.0 at the time of this recording. We want to be up to date and we want to use the latest thing possible. The first thing, as we learned, is we have to write our pragma directive. So we write pragma, and as I told you before, we're gonna use version 0.7.0. Cool. Well, I missed pragma solidity 0.7.0. So that's our pragma directive. Second thing we should do is declare our contract. So we do the contract, call it first contract, and there is that. So we have declared our first contract. Then it says it should have a state variable called count. Let's declare our state variable. So I told you guys before that Solidity is a strongly typed language. So you always have to declare what kind of variable it is when you first implement it. So our count variable is a integer. Always assume that it's always positive, so we can make it unsigned integer. I'll go over the difference between unsigned integer and integer later, but for now, just remember unsigned integer is always positive. Event count. And yes, so it's not inside any function, it's directly inside the contract, so it's a state variable. Second thing we need to do is assign a default value to this count state variable. Let's do that. And we will do that using something called a constructor function. What is a constructor function? A constructor function is something that runs only once when you deploy the contract. So it will run once and assign a default value to our state variable. We do a constructor, right? And that. So before 0.7.0, you had to declare this constructor function as public. But if we are using 0.7.0, we don't need to do this anymore. In fact, if we do this, we'll actually get a warning. It's not an error, it's just a warning. So we are using the new latest version, so we don't have to do this. And let's actually indent this code so it's easier to read. That's the contract, that's the constructor, and cool. So we will just make it 1 by default. We can make it 10. Okay, so we have a constructor function that gave it a default value. Now we need to write a getter function, get the state variable. So cool. So let's write a function with the keyword function, and we will name this function get count because it's getting the count, getting the value. It doesn't take in any parameters, and it is being called from outside. So it could be external or public. So we go with public. I'll again go over the details of public versus external later on in the class. For now, just follow along and make it public, and know that if you make it public, then you can call this function from outside. It's a view function because it does not change any state, but just returns the current state of the blockchain. It does not change anything. And it returns the unsigned integer value. So it returns the value of the count, and count itself is an unsigned integer. And what does it do? It just simply return count. That's all it does. Now, the next thing we need to do is write a function that adds a number to this variable, and we can pass in that number to that function. So let's do that. So again, we start the function with the keyword function, and we will call it add number. So to add number, we need to pass in the number. The number we pass in should also be an unsigned integer to keep things simple. So this function will get this parameter underscore number. Now, this underscore is nothing special. It just says this is only used inside the function. It's not a state variable. It's just a convention. You can just call it number actually. That makes it easier. And it's also public because we'll be calling this function from outside, and it doesn't really have to return anything. It just adds whatever number you pass in. The logic behind it is just count equals count plus number. So in Solidity, you should always use the semicolon at the end of each statement. So we have that, otherwise you'll throw it. That's all the logic there is to it. The last thing we need to do is subtract from this count variable, and that will be very similar to function we wrote here, add number. It will be just function subtract number. So let's write it out, subtract number. It also takes a event parameter, event number. It's also can be called from outside, so we just call it public, and count will just be count equals count minus number. Cool. Well, for the semicolon. Let's see if we can actually now compile it without any errors. Right, so we have written this. So we go to the compiler, we change the compiler version to 0.7 and above. Anything over 0.7 will do. Let's pick the latest one and let's just compile it. It did compile it because we got the ABI and the bytecode, but it threw an error. The error said the SPTX license identifier is not provided in this source file. This is not a problem. Regardless, let's just add the license type at the top because we don't want to see this ugly warning. So this is something that also got added in 0.7 version. Before that, it would not have thrown this warning. Again, it's a warning, not an error, but it's good to add it and not see this warning. So I just added this, and let's try and compile it. Good, the warning goes away. We still have ABI and bytecode, and it went through. So the next step is now to actually deploy this. So we go to the deploy tab. We check the JavaScript VM environment. That's what we have. We also have all these functions with all the fake ethers, and the gas limit for the transaction for deployment is set to this, and we are good to deploy. Let's see what happens. Oh, it got deployed really fast. That's cool. Cool. Now that we open it, we can actually interact with this contract. Let's see if everything works. So what should we get for get count? What do you guys think? Okay, if you think it's 10, the answer, you're right. Because we, by default, whenever we deployed it, this constructor ran and made this count 10. So if we do this, we get a 10. That's great. Now let's try and see this add number. This add number takes integer number and adds to it. So if we pass 2 here and click add number, this count variable should now go to 12 if the transaction actually goes through, which it does. We see it because there was no errors. And now if we hit get count, it should be 12. Cool, works. Now let's try and look at subtract number if it works. If I pass 4 here, it should now subtract 4 from 12 and it should be 8. Let's see if that works. Transaction again went through and I hit get count, it's 8. Awesome. So this first smart contract works, and if you followed along, congrats on your first smart contract. This is actually a good start. So now let's see what other improvements we can make to the smart contract. One improvement that we can make to the smart contract is somehow get rid of this constructor. We can actually assign the value right here where we initiate the contract. We can basically get rid of this constructor. So that makes our contract a little concise. Second thing we can do is actually name this count variable public. Whenever you name something public, it makes a getter function automatically for that state variable. So we don't need this getter function anymore. So we can just get rid of this. And now, yeah, so that's it. So our contract is much more concise. And let's see if we can actually compile it again. Oh, it compiled without any errors. Now let's see if we can deploy it. This was the first instance of deployment of the first contract. We'll get a second instance of deployment if actually the deployment goes through. It did, and as you can see, it has a different address than the first instance of the contract. So it went through. And okay, so we don't have get count anymore. We have count, which is the same name as the variable. So we have a getter function of the same name as the variable that automatically got generated, this getter function. If we hit it, we should get 10 again. Awesome, that works. Let's see if the add and subtract function still works. We add 5, should be 15 now. That works. Now if we add 10 here, subtract, it should be 5 now because it subtracted 10 from 15 and it's 5. So yeah, everything works. So this is your first contract and a better version of the first contract too. Cool. So this is it. Hopefully you learned a lot. See you in the next chapter.